we have to consider units when we're talking about applications of our derivatives. So first thing we want to do is take a look at derivatives. Remember, we've been taking derivatives and we've been talking about instantaneous rate of change. So when we talk about the derivative of a function, we're talking about the instantaneous rate of change with respect to its independent variable. And again, we've been looking primarily at x's and y's, and x as being our independent variable. So when we talk about a derivative, we know that we're talking about the change in y over the change in x. That's been our derivative. So when we talk about our units, you have to consider what the units of your dependent variable are and divide it by the units of the independent variable. So miles per hour, for example, when you're driving your cars, that's a derivative. Again, we're talking about the miles being the units of our dependent variable, hour being the units of the independent variable. So we're going to look at a lot of other functions instead of not just in terms of x and y. So if you take a look at this first example, they're giving you this function q of t. Notice instead of using an x, they're using a t. So my independent variable is t instead of being the x. So we're talking about a function which talks about modeling electric charge modeled in coulombs inside of a light bulb after t seconds when it's turned on. So the questions are simply asking us what would represent a method for finding the instantaneous rate of change. So again, instantaneous rate of change, when we talk about that instantaneous rate of change, remember that's just our derivative. So since I'm given the function q of t, the instantaneous rate of change is just going to be q prime of t. And there's only one answer choice that represents that derivative, which is going to have to be choice what? B. What would C be? Wouldn't be your instantaneous rate of change, but it would be your average rate of change over some time, over some interval. So when you take a look at example 2, again, when we talk about the units for f prime of x, it's the unit for f divided by the unit for x. Like I just mentioned, it's the units of your dependent variable divided by your units for your independent variable. So remember, when we talk about f prime of s or f prime of x, remember it's the change in y over the change in your s, whatever your independent variable is. So when you take a look at this example, they're giving you a function t is equal to f of s. So again, my numerator is going to be my change in t over my change in s. So now here they're asking me for what are my units for f double prime of s. So notice they're telling you that t is being measured in hours. So I know my units for my dependent variable are hours. The size of the sample, that's my independent variable, is being measured in milliliters. So this would be how I'd measure my first derivative. What do you think the second derivative would be, the units? Yeah, squared, so hours per milliliter squared. So for my second derivative, it's going to be hours per milliliter or a milliliter squared. So it's got to be choice C. You can also write this as hours per milliliters squared. That's acceptable as well. So just making sure you're comfortable in terms of writing the units when we get into these problems with application. Okay, so like I said, we're going to move into one application of derivatives, which is going to get into velocity and acceleration. So when we talk about all of these motion problems, we're really looking at rectilinear motion. So when we talk about rectilinear motion, we're talking about a particle that's moving in a direction. Again, the line may be the x-axis, the y-axis, or some other straight line, or the general coordinate line, we call it, is the s-axis when we're talking about position. So when we're looking at these motion problems, they'll be giving us one function, and typically they will identify it as S of t. S of t is the position function. Think of this just like your f of x. That's the coordinate of the particle at a particular time. So that'll be identified as your S of t. Okay, so let's take a look at this first graph. Always pay attention to what graph they're giving you. Sometimes they'll give you the position graph, sometimes they'll give you the velocity graph. Here they're giving the position versus time graph. And again, for a particle moving along the x-axis, so in words, they want us to describe how the position of the particle changes with time. So for example, starting at t is equal to 0. At t is equal to 0, the position of the particle is at S of 0 is equal to -3. So the position of my particle is -3 at time t is equal to 0. Then what happens is my particle starts moving. So as you can see from the graph, from t is equal to 0 to t is equal to 4. This graph is increasing. The graph of S is increasing. So when your position function is increasing, so from t is equal to 0 to t is equal to 4, S of t, the graph is increasing. So what that means in terms of the position of this particular particle is the particle is moving in the positive direction. So when your S of t is increasing, your particle is moving in the positive direction. Does it sound familiar, physics people? Sadly, I'm sorry. And you guys could probably explain it better to me because it's been a long time since I've had physics, nor do I want to go back and ever take physics again. Okay, so then notice what happens from t is equal to 4 to t is equal to 7. So from t is equal to 4 to 7, notice my position graph is decreasing. So from t is equal to 4, from t is equal to 4 to t is equal to 7, notice my S of t is decreasing. So I'm going to take a wild guess what's going to happen with the particle then? It's going to move in the negative direction. Yeah. Yeah, or you can write it like with like a interval notation as well. That's fine. So again, because when S of t is decreasing, it's moving in a negative direction. Okay. So what's happening from t is equal to 7 to 10? Constant. So yeah, if you want to write this like that, that's absolutely fine from 7 to 10. I think that's what you were saying, Addie, right? Yeah. So from 7 to 10, again, S of t is constant. So what does that mean? What's happening with a particle? It's not moving, it's at rest. So any questions when you're given the position function, how you know if a particle is moving in a positive or negative direction or at rest? So again, always pay attention to what graph they're giving me. Now, let me ask you this, going back to the graph of the position. we've sketched and we've been looking at tangent lines. So when you look at this graph at this interval where it's increasing, what can you tell me about the slope of all the tangent lines? So when this graph is increasing, what's happening with the slope of all these tangent lines? They are what? Positive. So what you're actually looking at is you're looking at the graph of the derivative right there. That's what we're talking about, is what's happening with the derivative of the position function. Again, velocity is the first derivative of your position function, and velocity describes how fast and in what direction a particle is moving. So again, your velocity function is the first derivative of your position function. So you're taking the derivative of the position function with respect to time. So ds over dt. So what we just analyzed when I was looking at where the intervals of this graph were increasing and decreasing, what we were looking at is we were looking to see whether your velocity was positive or negative. So three things can tell us, velocity can tell us in terms of the particle moving. So when v of t is greater than 0, it means that your position is increasing with time, so the particle is moving in the positive direction, as I just showed you. So from the graph, if I give you the graph of the position, you're looking to see where is that position function increasing or decreasing, or velocity is greater than 0. If your velocity is less than 0, it means it's decreasing with time, so the particle is moving in the negative direction. So when your velocity is equal to 0, it means that the object has momentarily stopped. When we talk about velocity, just to make sure we're clarifying things, when we talk about v of t is the instantaneous velocity of the function. Just to distinguish it from average velocity, but frequently that instantaneous is not is omitted when we're talking about velocity. So like I said, when we talk about that phrase velocity, we're talking about instantaneous velocity. So another application that we talk about with derivative is speed. Describes how fast the particle is moving. And that's simply just going to be the absolute value of your velocity function. Speed is never negative. It tells us how fast we're going, but it doesn't tell us anything about the direction. Another function we'll look at is acceleration. And that's the rate at which the velocity is changing over time. So your acceleration is actually the first derivative of the velocity function, or it's the second derivative of your position function. Anybody know what the third derivative is? Jerk, yeah. We don't really talk that much about jerk, but there is a third derivative jerk that's out there. You do that probably in physics, yes? This is why you don't take physics. Okay. So let's talk about given your position function, and a lot of times when we are talking about rectilinear motion and we're talking about position and time, they're going to give us that restriction that t is greater than or equal to 0 because we're talking about time. We typically don't have -5 seconds or negative time. So typically you'll see that t is greater than or equal to 0. So for part A, find velocity, speed, and the acceleration function. So first of all, I know that velocity is just simply the first derivative of the position function. So all I need to do is take the derivative of the position function. So that's going to give me 4t minus 8. Speed. Speed is just the absolute value of your velocity function. So my speed function then is just going to be the absolute value of 4t minus 8. My acceleration is going to be the second derivative of my position function or just the first derivative of the velocity function. So then my acceleration function is just going to be 4. So any questions on if I give you the position function, how we can find velocity, speed, acceleration? All of you go ahead and answer part B for me. Find your velocity, speed, and acceleration at t is equal to 1. So did we come up with this? Any questions? Again, just plugging into 1. Remember, if you end up with a constant, for example, the acceleration is a constant 4 meters per second squared. Don't forget your units. Again, they told you in the problem that S is in meters and T is in seconds, so don't forget your units. Okay, questions on that? Now let's jump back into some algebra time, and now the second part is asking us to graph. So they want us to graph all 4 functions: position, velocity, speed, and acceleration. So if you take a look at your position function, S of t, it's a quadratic. So again, what I'm going to do is I'm going to factor out that 2t and find where this parabola is going to intersect my x-axis. Again, I'm just doing rough sketches. They don't need to be perfect. So I know that this parabola is going to intersect my x-axis at t is equal to 0 and 4, correct? Again, I'm only concerning myself where t is going to be greater than or equal to 0. So again, I know that the parabola is probably going to look something like this. Just a sketch.
Or you don't use like the coefficient of the first term.
I'm sorry, Alan, what did you say?
You can use the coefficient of like the first term to find like the steepness of the graph.
Yeah. Yep. And I know it's going to be opening up because t squared is positive. So then to do my velocity, velocity is just a line. Y-intercept is -8. Find where it's going to cross my x-axis. It's going to cross my x-axis at 2. Remember, it's only where t is greater than or equal to 0, so my graph will look something like this. Okay, so any questions about graphing position or velocity? Next one is speed. So now you got to remember how to graph absolute value functions. What's the shape of an absolute value function? The V. So again, what I'm going to do is factor that 4 out. The reason why I want to factor that 4 out is because I want to find the vertex of the V. Remember, the coefficient of t needs to be 1 in order to figure that out. So where is this vertex going to hit the x-axis? 2. What's that 4 that I factored out going to do? Do you remember? Yeah, it's just like remember, it's the horizontal compression. So I know it's going to intersect my y-axis when I plug in 0 for t. Again, it's going to intersect up here at 8. So there's my speed function. Yeah, because it's going on forever. Yeah. Yes. Are we okay?
Was it really small spider that they're freaking out about?
One of my many talents. So any questions, again, if they ask you to graph the different functions, just remembering how you graph all, again, because it's t is greater than or equal to 0, just make sure you don't go past that y-axis when you graph them. Yes. Because the restriction is t is greater than or equal to 0. So that's why I don't have a part of the graph to the left of the y-axis. Okay, now we're going to talk about speed. Again, we're going to talk about speed. What was the question? On the what?
On the wire stuff.
Right, because it's t is just greater than or equal to 0. Okay, yeah. So next thing we're going to talk about is speed. And in terms of, ladies and gentlemen, one thing you have to be able to determine is if the particle is speeding up or slowing down. The picture kind of got shifted when I Xerox, so let me kind of explain in words because part of the words got covered up. To determine if an object is speeding up or slowing down, what we have to do in order for an object to be speeding up, and I'm just abbreviating speeding up with SU, your velocity and acceleration have to have the same sign. So they're either going to be both positive or they can be both negative. So in order for a particle to be speeding up, your velocity and acceleration have to have the same the same sign, both positive or both negative. To be slowing down, and I'm going to abbreviate slowing down as SD, your velocity and acceleration will have opposite signs. So one could be positive, the other one could be negative. Doesn't matter. So now notice, always pay attention to the graph they're giving us. So let's determine the speed given a graph. Again, you're looking at the velocity graph. They're giving me the velocity graph. So they want me to determine what's happening with my speed on these different intervals. So if I look from 0 to A, right here. So tell me about the velocity values. Again, I'm below the x-axis. So is velocity negative or positive down there? Negative, because these are all going to be negative y values. Now, acceleration, remember, is the derivative of the velocity function. So what I want to do is kind of view or look at what's the slope of all these individual tangent lines. The slope of all these tangent lines are what? Negative. So again, if the slope of my tangent lines are negative, my acceleration is also going to be negative. So what does that tell me about my speed? Is it increasing or decreasing? Increasing. Again, they may use that phrase speeding up, slowing down, or speed could be increasing or decreasing. So any questions given the graph of the velocity, how I know what's happening with the speed? Yes.
So like halfway through on the bottom part, the bottom's velocity, right?
Yes.
So the halfway through A, is it decelerating and then it starts accelerating, it's going back up, right?
Well, it doesn't start going back up until you get right down here.
But like
So then we're going to go from A to B. So then from A to B, if you take a look from A to B, what's happening with velocity? Is velocity still negative? Yes, but what's happening with your acceleration? It's positive because you can see that the slope of all these tangent lines are positive. So since velocity is negative and acceleration is positive, what's happening with your speed? It's going to be what? Decreasing. So go ahead and do the next couple intervals for me. Tell me what's happening with the speed over those next couple intervals. Suppose instead of looking at velocity, you're looking at a position versus time curve. So you have a position graph, your S of t, and you're looking at what's happening at time t sub 0. So first of all, you can see from the graph, because you're above the x-axis, that the position is greater than 0. It's because the particle is on the positive side of the origin. You can see that the curve has a positive slope. So that tells you that your velocity is greater than 0. The curve is concave down. We'll talk a lot about concavity later on, but concavity is when you're looking at a position curve will help you determine acceleration. If your curve is concave down, then your A of t is going to be less than 0. So right here at the next curve, your position is still greater than 0 because you're on the positive side. You can see your curve has a negative slope, so that means your B of t is less than 0. And you can see that the curve is still concave down, so your acceleration will be less than 0. Again, when you're looking at position, if you have the position curve, you look at the concavity to help you determine what's happening with acceleration. So you can see right here in this third graph, at t sub 0, you're below that x-axis, so you know that your position has to be less than 0. You can see that you have a negative slope. So your velocity has to be less than 0. Now in this picture, your curve is concave up. So what that tells you, your acceleration has to be greater than 0. So finally, the last graph, you can see that at t sub 0, your position is greater than 0. Now, what's happening at t sub 0? What's happening with your slope here? There is 0. So that tells you that your velocity is equal to 0. And your curve is concave down. So again, when your velocity is equal to 0, remember that tells you the particle is momentarily stopped. And again, concave down, your acceleration is less than 0. So remember what we just talked about? A particle is speeding up when its velocity and acceleration have the same sign, and it's slowing down when they have opposite signs. So now in the previous graph, I gave you the velocity graph. Now pay attention. I'm not giving you the velocity graph. I'm giving you the position graph. Always pay attention to the graph that's given to you. Still going to figure out what's happening with the speed, but now I'm giving you a different function. So you still have to figure out what's happening with velocity and acceleration. Velocity, again, because I'm giving the position, I'm going to look at the slope of my tangent lines, if it's increasing or decreasing. For acceleration from the position graph, I got to look at the concavity. So take a look at this particular graph, and let's take a look, first of all, starting from t is equal to 0 to 2. So let's start with 0 to 2. Tell me about velocity, which again, I'm looking at the slope of my tangent lines. Remember, my velocity is going to be the slope of tangent lines. What's happening with the slope of all these tangent lines? Are they positive or negative? Positive. So I know that b is greater than 0. Remember, for acceleration, I'm looking at concavity. So what's happening from 0 to 2? Is that graph concave up or concave down? So that means that my acceleration is going to be greater than 0. So since velocity is positive, acceleration is positive, tell me what's happening with this, is the speed. Is it increasing or decreasing? Increasing. So I know this object is going to be speeding up. So now let's take a look from 2 to 4. What's happening with my velocity from 2 to 4? It's great, it's positive. So I know my velocity is going to be greater than 0. What's happening with a concavity? Is it concave up or concave down? Down. So what does that tell me about my acceleration? My acceleration is less than 0. So what does that tell me about my speed? Is it speeding up or slowing down? Slowing down. Go ahead and do the interval for me then from 4 to 7. We all get it speeding up from 4 to 7?
Yes.
Now what's happening from 7 to 10? So it's a constant, correct? Because I know that v is equal to 0. So what's happening with this particle? Is there any speed? No, there's no speed. Okay, the object is stopped. The particle is stopped. So any questions? So we've done speed given the velocity graph. We've done speed given the position graph and acceleration. I mean, the position and the velocity. Okay, yes.
So this might be a dumb question. but-
No, no questions. Sir.
So is acceleration a vector?
In order to have the vector, it has to have direction and time. So you can have,
Oh, so there's like negative.
you can have negative acceleration. Yep. So last two things and then we're done. So again, there's what's called displacement. And that's just the change in the position over some particular time interval. So to find your displacement, they have to give you a time interval. And what you're going to do is simply plug those endpoints into your position function and find the difference. Can displacement be equal to 0? Yes. Let's say we start at this particular point. I travel, and I end up to the beginning. So my displacement 0, because I didn't change position over that particular time interval. Okay. Now, let's talk about total distance traveled. So if I want to know how far I traveled in a particular time interval, could that be equal to 0 given the diagram that I just gave you? No. Remember, when we talk about a distance, distance is always a positive number. So distance is always positive. What we're going to have to do is take the absolute value in any negative velocity intervals to figure out what my total distance traveled is going to be. So the way you find, so these are kind of your steps to find the total distance traveled. What you want to do is you want to find where your velocity is equal to 0 in that particular interval. So if I want to find total distance traveled from 0 to 5, I want to set my velocity equal to 0. You then have to calculate or separate the intervals into where your velocity is positive and where it's negative. And I'll show you how we do that in a minute. We'll do a number line test. Calculate the distance traveled in each interval by substituting into the position function. If you have any negative velocity intervals, you're going to have to take the absolute value. And then you add up all your distances from each interval to get the total distance. Remember, distance traveled is always positive. Displacement can be negative, displacement can be 0. So determine the time interval where your particle is speeding up and slowing down. So again, notice they're giving me the position function. To determine your time interval where you're speeding up and slowing down, you've got to figure out where is velocity positive and negative, where is acceleration positive or negative. So the first thing you have to do is find your velocity function. That means I'm going to take the derivative. So that's going to be 9t squared minus 36t. So now the way you determine where your velocity is positive or negative, what you're going to do is you're going to set your velocity function equal to 0. So I'm going to go ahead and factor out that 9t. And then you solve. So your velocity can only change sign if it has equal to 0 at certain points. So the velocity can only change from a positive to a negative or negative to a positive at those time intervals from 0 to 4. So then what we're going to do is do a number line test. You're going to get tired of doing number line tests. So what you're going to do, what I want to know is whether velocity is positive or negative between 0 and 4. So you pick a test number. Pick any number between 0 and 4. Don't use 0, don't use 4. Pick any number between 0 and 4. You take the 1, you plug it back into your velocity function. Plug it back into the one that's factored. It's easier. You don't need to actually calculate the number. You just have to know whether it's positive or negative. So when I plug 1 into my velocity function, would I get a negative number or a positive number? Negative. So I know that my velocity is going to be negative between 1 and 4. Now I need to know what's happening for my t values greater than 4. So pick a test number, I'll plug in 5. Still plugging into velocity. If I plug 5 into velocity, what happens? Is it positive or negative? Positive. So we've done figuring out velocity, whether velocity is positive or negative, given a position curve or given the velocity curve. Now we're figuring it out algebraically. So now I need to know what's happening with acceleration. So I have to find my acceleration function. So I have to take the derivative of my velocity function. So that's going to give me 18t minus 36. So again, to know whether acceleration is negative or positive, I have to set my acceleration function equal to 0. And again, I'm going to go ahead and factor out that 18. So the only place where acceleration can change from a negative to a positive or positive to a negative is at t is equal to 2. So I'm going to make another number line. Some people just make one number line and may use different colors. I always like to do 2 number lines. That's completely up to you. Remember, you're starting at 0 and you're checking what's happening between 0 and 2 and then 2 to infinity. Because t, they already told you in the problem that t is greater than or equal to 0. Again, plug in a test number just like I did with velocity, but now I want to check acceleration. So I'm going to take 1, plug it into my acceleration function. So when I plug in 1 into acceleration, is that a negative or a positive number? Negative. So I know my acceleration is negative between 0 and 2. What's happening when I plug in a number greater than 2? If I plug in 3, it's going to be what? Positive. So now you want to kind of put both number lines together. Remember, from 0 to 2, my acceleration is negative. So velocity is negative from 0 to 2. Acceleration is negative from 0 to 2. So where is this going to be speeding up? It's going to be speeding up from where? 0 to 2. Now remember, from 2 to infinity, your acceleration is positive. So what's happening from 2 to 4? From 2 to 4, it's going to be slowing down. And notice from 4 to infinity, your velocity is positive. From 2 to infinity, your acceleration is positive. So I'm also going to be speeding up from 4 to infinity. Okay, we're gonna have to finish the last two, next, not next class, because we're taking the test, but the class after that.